Hello, welcome to the last video for this course, the last day of notes. This is probably my favorite day in all of probability, and that's learning about expected value. This is hopefully a day where you could see the usefulness of it. This is really where you start to get into decision making and how to make decisions that are beneficial to you, okay? So we're gonna look at this lottery ticket as an example, okay? You buy a lottery ticket for $5. You have a 20% chance of winning $10, a 2% chance of winning $20, and a 1% chance of winning $100, okay? So we've got all those amounts and we've got all those percents. Now, this first question was kind of like a class discussion. So I'm just going to kind of skip down to applying this formula that we have. All right, this formula is for the expected value of something, okay? And I know this looks complicated. I'm going to show you how to use it, okay? For expected value, all right, you are taking, you're looking at all the outcomes, okay? And you're taking the value of the outcome multiplied by the probability of that outcome. Okay, so for example, if we look at our first outcome right here, we have a 20% chance that we're gonna win $10, okay? So we wanna take that into account, okay? 20%, that's 0.20 as a decimal, that we win $10. Now, we spent $5, all right? So part of this is understanding like transactions, okay? If we spend $5 in order to make $10, we have a net gain of $5, okay? So we're not gonna put 10 in here, we're gonna put 5. So that's our first outcome. So we're gonna add that to, we have a 2% chance of winning $20. So now we wanna put 2% as a decimal, that's 0.02 of winning $20. And again, we spent 5 in order to make that 20. So that's getting us a net total of $15. So we have a 2% chance of making $15, and then a 1% chance of winning $100. So 1%, that's 0.01 times 100. Nope, not times 100. I'm already forgetting. Again, we spent the $5, so we're actually only making $95, okay? So those are the three outcomes for winning. Now, there actually is another outcome. If you look at all these percents, that only adds up to 23%. So if we have a 23% chance, of winning anything, that also means that we are going to have a 77% chance of losing, all right? And so we spent $5 on the lottery ticket, so we have a 77% chance that we're gonna lose our $5, okay? And what we wanna do is we want to take this and we want to type this whole thing into our calculator. Now I know this is big and it's long, but that doesn't really matter. It shouldn't take you more than like 30 seconds to type this in, okay? And when you do that, you should get negative $1.6. So how can we interpret that? Well, this is saying that on average, you're losing $1.60 per lottery ticket. Okay, and so if you bought a bunch of lottery tickets over time, you would be actually losing money. So this is actually not a good investment, as most lotteries are, okay? So that's what you're doing for expected value. You're taking all the probabilities and multiplying it by the value of that actual outcome, okay? So we're gonna look at two more examples here, all right? This one is about a restaurant and how much profit they make per serving, which means just like serving the meal one time. And then also the percent of time that they sell that meal. Now, the reason we wanna look at this is because not all meals are sold equally. So they want us to find the average profit from each meal, okay? Well, we wanna look at, all of the meals together. We can't just add up these numbers and divide by 4 because they're selling the lasagna a lot more than they're selling the soup, okay? So that's gonna actually raise the average profit because they're making more off lasagna than they are off soup, okay? So what we're going to do is we're going to use our expected value formula, and we have 4 different outcomes, all right? One for each. So we have the stew. So there's a 12% chance that someone buys stew, which means that the restaurant will make 34 cents. There's a 7% chance they'll buy the soup, where the restaurant will make 0.41 cents. There's a 45% chance they'll sell lasagna, which is 64 cents. So you see how we're doing the probability of each outcome multiplied by the value of that outcome, and we're adding them all together. Then we've got a 36% chance for the chili, which is 73 cents, okay? So if we do all that and we add it all up, that gives us an answer of 0.62, okay? So on average, for every meal they sell, regardless of what the meal is, they're making about 62 cents per meal. And what he can actually do with that is now he can answer this question. If the owner had 200 meals ordered in a day, what could he expect his profits to be? Well, if he has 200 meals and he's getting 62 cents per meal, in total, he's going to make about $124, okay? And that is, it's not every single time. Sometimes you might have more of one thing on one day than another. But again, expected value is just all about the average over time, okay? So that is what we do for that problem. Last one we're going to look at, a charity spinner, okay? So the charity is considering a fundraising event in which donors will pay $1 to spin the wheel 3 times, okay? And it says here that if they get 3 even numbers, they win an item worth $4, okay? So the charity wants to know what is their expected payoff each time someone plays. So what we want to do is first we want to find out what's the probability of someone actually winning this game, okay? So they're going to spin 3 times and get 3 even numbers, okay? So what we want to do is first we want to find what's the probability of getting an even number. Well, we have 6 numbers on here, and we have 3 even numbers, so that's 3 out of 6, which is a half. So there's 1/2 chance that you're going to get an even number. Now, if they spin it 3 times and get 3 even numbers, that's getting an even number on the first spin and the second spin and the third spin. So remember, and is multiplication. So getting an even number on all 3 spins is 1/2 times 1/2 times 1/2, which is 1/8. So the probability of someone winning their game is 1/8, 1 out of 8 times. And so we can use that to figure out the expected value. So 1/8 chance that someone wins the game and a 7/8 chance that someone loses the game, right? And so now we just want to look at, okay, what is the value for the charity each time someone wins or loses the game, okay? So if someone wins the game, they win an item worth $4. So the charity is, paying out $4 to that person. But that person had to pay $1 to do the spin. So the charity is paying out $4 and bringing in $1. In total, the charity is losing $3, all right? If someone loses the game, they don't get any prize, and they just had to pay the $1, so the church makes $1, okay? So we've got a 1/8 chance the church loses $3 and a 7/8 chance the church makes $1, okay? And so if we look at all of that in total, we have, this is 0.5. So this actually is a good raffle or a good game for the charity, because this is in the positives. Essentially, if this is in the positives, then it's good because you're going to be making money. And if it's in the negatives, it's bad because you're going to be losing money, okay? So this is how to do this. So we use the same formula 3 times. Hopefully this kind of made sense to you. We're not going to do example 4. It's just kind of long and a waste of time, I now realize. So you got 3 practice problems I want you to try. If you have questions on these, you can send me your answers or ask me to go over them, and I'd be more than happy to do that. But yeah, so if you have any questions, let me know, and have a great day.